President Cyril Ramaphosa announced the formal lifting of the national state of disaster. You've already forgotten about the national state of disaster, but in the UK it appears there are now concerns of what's being described not as a new variant, but as a new mutant variant of COVID-19. So it's different to an entirely new variant, can still lead to serious problems. Dr. Nicole Wolter is a principal medical scientist at the Centre for Respiratory Diseases and Meningitis at the National Institute for Communicable Diseases. Dr. Wolter, good afternoon to you, and thank you for your time. You're going to have to start me off at the beginning here. I understand this is called a mutant strain of two other variants. What's different about this mutant variant compared to what we understand to be a variant?
Hi, Stephen. Thanks for having me on today. Yes, I think it's just to put it in perspective, it's nothing different to what we have been seeing. I think we know that viruses are known to evolve and mutate over time, and this is very much normal and expected for viruses, and even so the case for SARS-CoV-2. What we are seeing is some recombination between different variants. So this is not so much as I don't want to raise any alarm. It's not a mutant variant. We have mutants all the time. All of the variants that we've had previously are mutants of the same virus. It's just what we have been seeing in a couple of the countries. What seems to be popping up is more recombinations between different variants. And this is what we call a recombinant virus. So it's where it's part of the genetic material from one variant combines with the genetic material of another variant to create this new, what is known as XE. So XE is a combination between two different Omicron sublineages, so that's BA1 and BA2, which have now combined their genetic material, so contains a portion of BA1 and a portion of BA2, and this results in what we have detected as XE. Just to note that there are others. There's XD, there's XF, there's a number of different ones that are being picked up. Some of them are combinations between Delta and Omicron. So it's really just what we're seeing is as these viruses co-circulate and potentially co-infect a person, we see recombination between the different variants.
So when you say they co-infect a person, does that mean that this variant probably was because one person got two variants at the same time?
Yes, most likely that is the case. So viruses evolve in different ways. The one is through random mutations that occur during replication process, whereas where we get spontaneous mutations that we pick up. This is a different method of evolution where you get two different viruses that most likely were infecting the same person that then recombine their genetic material to form a new variant or a new sublineage.
Okay, so if it's made out of two variants, or actually sort of different types of one variant that we know about in terms of Omicron, and if we already have a lot of immunity in this country, say to Alpha, Beta, Omicron, Delta, etc., would you expect then that most of us would have some immunity to this new, recombinant variation?
That is what we're hoping for. So we can't really say. The numbers are very small. So just to this, recombinant was picked up in the UK in mid-January. I think there's about 700 sequences now being detected in the United Kingdom. And while it's shown up in a few other countries, we have to date no XE detected in South Africa. But we are continuously monitoring the sequences. We do regular sequencing of all sequences in South Africa, all cases. We do a random selection. We sequence. So we're continuously looking, but so far we have not found this particular recombinant in South Africa yet. And it's difficult to predict. There's not enough data from those other countries where it has been found to know and understand the effect it'll have on transmissibility or severity. But we do expect, because we have had Omicron and a number of other waves, and those have all shown with Omicron that we have reduced severity due to prior immunity, we expect this is likely to be the case as well with this new recombinant, but we'll have to wait and see. The numbers are too small in other countries to make any conclusions yet.
Is it likely, I mean, it may not be possible to answer this question, if everybody in the world had been vaccinated, or a much higher proportion of people had been vaccinated, would it have made it less likely for this new variant to sort of find, for two different types of this disease, to find one person to infect at the same time, to create this new variant, in other words?
Yes, definitely. So immunity, although it doesn't not 100% effective at preventing infection, it has been shown to reduce infection and reduce the duration of infection. So definitely the fact that individuals who are vaccinated would be less likely to be infected, and also if they were infected to develop less severe disease and have lower loads of the virus, it would prevent these sort of events from occurring.
The optimistic scenario, if I can call it that, I am a journalist, but I still try to be an optimist, I have to pay my fees regularly, would suggest that as the virus evolves, it's doing that to try and exist in a patient for longer, which means that it may cause less severe symptoms. Is that your understanding? Is that still a possible scenario, even though we have the new subvariant that we're talking about now, that actually we could still find that COVID just produces less and less severe symptoms?
So, yes, I mean, that is what we've seen, and it's not necessarily a mutation of the virus, but also an adaptation of the human response. So remember, this was a completely new virus. Our bodies were naive. We had no antibodies. And what's been happening over the last 2 years is we've been developing and maturing antibody responses, either through infection or through vaccination. And what we see through the data is that this really protects us from developing severe disease. So even though we may get some immune escape, like we saw with Omicron, because of the robust T cell immune response that's generated through prior infection, we don't see as much severe disease. So I don't know if you can attribute it to the virus. We never know with the virus what mutations will arise, whether that increases or decreases the pathogenicity of the virus, but definitely having this prior population immunity does seem to be protective against severe disease.
Dr. Nicole Wolter, thank you very much indeed for that explanation. Principal Scientist at the Center for Respiratory Diseases and Meningitis at the NICD.